Okay. Whenever you guys are ready.
Yeah. Do you want to connect in first?
Yeah.
Let's just, if you can pull up the Skylo website, that'd be great.
Yes.
Figure that out. You need Wi-Fi?
I'm on the hotspot. All right. We're speaking.
Just let that play. Just let that video play. That's right.
It's great. Want me to introduce you guys?
Look at that video.
You got it? Okay.
Whenever we're ready.
I think we're ready. Let's go.
Okay, awesome. Thank you all for joining. I'm Parth Trivedi. Really excited to be here because MIT is home, class of 2014, course 16. I've got with me my colleague from Monogoto, Itamar.
I'm Itamar. How are you?
And so Skylo and Monogoto have partnered together for this particular track in the hackathon. This is the satellite connectivity track. And I'll tell you a little bit about what we do. So historically, if you wanted to connect anything over satellite, you would have to do it using a big satellite antenna, like a dish. It would be a very expensive solution. It would not be compatible with cellular connectivity, and it would be basically a pain in the ass to connect. Now what we've done is we have taken satellite connectivity protocols, we have imbued them into cellular chipsets. We have created a converged cellular and satellite solution that just works with existing cellular devices. And that's what Skylo has done, working in collaboration with the world's largest chipset companies like Qualcomm and Samsung. And this new capability we are offering through the connectivity partners that IoT developers, cellular developers already use. Monogoto is one such company that is one of the leading providers of IoT connectivity for the developer ecosystem. So we've partnered with them for this hackathon and this challenge. And they're also providing connectivity for real life use cases, which are already commercialized and in the field using our network across 4 continents. So Itamar, I'm going to hand it over to you to talk a little bit about the kit that we have here and how we can help developers get started.
All right. Thank you very much, Parth. It's great being here, guys. And I'm seeing some familiar faces. You've been working on the kit, so great job and great progress. I want to share some scope with you, tell you which company does which part so you'll understand, and show you a little bit of our APIs and how you can get started with them. So it all starts with the kit that we have here today, and this really shows us the entire life cycle. So you've got someone that generates information. It can be a human with his heart. It can be a car that is driving. It can be birds that you want to listen to, but something is generating events, generating information. The next part is that you need some processing power. You need something to read that part, to listen to it, or to just basically monitor it. You can use any type of MCU or CPU, any type of CPU that runs. Here we have a Raspberry Pi. So we're using the Raspberry Pi as an example, as a prototype of a sensor. At the end of the day, if you commercialize a product, you'll have a wearable device, or you can have something that you install on top of a pole or on top of the tree. That is the unit that runs literally the horsepower. All right, that's not enough. You need to communicate. How do you communicate? You're using a cellular modem. Here today, what we're using is the Murata development board that allows you to use it as an evaluation kit. The cellular modem that you have here is very similar to what you have on your phones, what you have in a wearable device, or in any junction where you can see the traffic lights are being monitored remotely. They have the same thing. It's a cellular modem. Here it's just a bigger form factor. Why? Because we're trying to develop, we want to see more stuff, we want to be able to fine tune and fine control it. At the end of the day, when you go into production with the device, you go through a process of miniaturization. You will take, instead of a Raspberry Pi, you'll take a smaller and better suited electronics. And instead of this external modem, you'll build something internally. At the moment, for the development process, we're using a Raspberry Pi and we're using this Murata development board. So one thing that cellular technology needs, and we're all familiar with that because we had to stand in line in AT&T or T-Mobile, you need a SIM card. What's the SIM card? Basically, it's a tiny computer. The SIM card has memory, it has a file system, it can run programs. But for our purposes, it's just an encryption key that allows you to connect to the network. So we started with a Raspberry Pi that monitors maybe some audio of some birds. We moved into the cellular modem that allows us to connect, and then we put the SIM card inside. The SIM card that you have inside is by Monogoto. We are the service provider that gives you access to the internet. We do it in 180 countries and in 600 networks around the world. So for example, some of you that worked with our kids here, some of you connected to T-Mobile, some of you connected to AT&T, some of you connected to US Cellular. The Monogoto abstraction layer makes sure that you don't care which network you're connected to. We'll try to connect to all of them. But everything that you've configured inside of Monogoto network, and I will show this to you soon, everything that you configured inside Monogoto will remain the same, even if you switch from AT&T to T-Mobile, and if you're now taking a trip and you're in Mexico or you're in Canada, everything will work exactly the same. So where we are in the life cycle, we have the Raspberry Pi listening or watching, getting some info, run some processing, and then that data is being sent with a cellular modem that has the Monogoto SIM card inside. Now, as we spoke before, only 20% of this Earth is covered by cellular. What happens in places when there is no cellular coverage? So this cellular modem knows to connect not only to the AT&Ts and the T-Mobiles of the world, not only to terrestrial network, but also to non-terrestrial network, to the satellite. And this is where our partners come in. So you have the SIM card by Monogoto, and you take this device and you deploy it all around the world. But what happens if I'm now in a boat and I'm sailing and I want to know what's the temperature of the engine, and if there is an emergency, I want to send communication in the middle of the sea. There is no cellular coverage. So this is where you will switch the communication module and you will tell it, you know what, I want to enable satellite. Now, guys, this is the place where we control the story. We control the narrative. It all depends on the user experience. Sometimes you want to say, this should only be on satellite all the time. Sometimes you want to say, no, 99% of the time, I'm using public networks. I'm using Telefonica or NTN or T-Mobile or AT&T. So it's up to you to decide on the business logic. I'll give you an example from a real life customer that is saying, for 20 minutes without coverage, only then enable the satellite. Why? Because maybe I'm just in an area for 2-3 minutes without coverage. So this is where your business logic, your algorithm really comes into play. So you have the device, it's listening to the birds because we want to notice which birds are coming in and out. And you got a Raspberry Pi processing that data, and you're using this board with Monogoto SIM card to send the information. Now you're switching to satellite. So at this point, the board is communicating with satellite, negotiating, but at the end of the day, for your purposes, this is yet another network. You don't see any difference. Same IP address, same firewall ports and rules, same blocking. Everything remains exactly the same. And that's the beauty about the Monogoto platform. We abstract all the lower levels so you don't have to deal with that. So you gave a command to the board, please switch to satellite. Now the board is connected to satellite. What are the differences? So the first thing, and it's easy because all of you spoke with us about this, the bandwidth is a little bit different. You don't want to go live streaming via satellite. It will cost you a little bit more and it will be slower. So you want to have your business logic noticing which scenario am I in? Am I connected to Wi-Fi, to public cellular networks, to private 4G, 5G, or to satellite, and adapting your code accordingly. So now you're connected to satellites, or you're not sending a full buffer. You're saying, okay, let's just send some heartbeat and let's send some smaller pieces of information. All right. How do you control all of that? As I mentioned, in order to get to the satellite network, you need the Monogoto SIM card, which you all have inside, and you control the Monogoto SIM card from the Monogoto dashboard. So most of you already received the login. If you didn't, I'll provide you later on. You can register, you can self-service yourself. Just go to monogoto.io and create an account. And what you do once you have an account is that you log in and you can see all your SIM cards. For these purposes, we've created an account. We called it HackMIT, and we put all the SIM cards inside, right? So you can see each other. So let's see how this one looks. So. All right. So I've logged in to the HackMIT account, and now I can see all my SIM. I can see all my things. We call them things. And I can control policies and security and management, and I can go very deep. But for these purposes, we'll stay very high level. So I'm logged in, I can see 2 active devices at the moment, and I can see how much they transmit, etc. But let's look at the things that we have. So we've got 68 things provisioned here, and we can see some of them are communicating, some of them are not, some on T-Mobile, some on AT&T. So let's go into a specific thing and look at what's happening. So now I'm in a specific device and a specific thing page. I can see the device, the network that it's connected to, when data was sent, when not, is it online, and I can actually see the low-level information from the infrastructure, from the cellular network. Now, why should we see low-level information? Is there something we need to do with it? Most of the times, no, you just want it connected. But think about this AWS mentality that says, if you want information, you have it. Not everyone needs it. So we've got some customers that subscribe to these events and they are doing predictive maintenance. They're looking at firmware optimization. So they have, let's say, 500,000 units deployed, and they're rolling out a new software version, a new firmware version for the hardware. And these guys will just slowly roll it out, and they will compare how is this one behaving, how is this one behaving, not only from software perspective, but also from the infrastructure perspective. How many times is the device booting up? How many times is it connecting to the network? Is he using a single network or a multiple network? All of these can be defined with this live event stream. You can subscribe to, monitor it, and run some stuff. But basically, when you don't need it, it's just there. So this device is connected. There are a few things we can do. The most important one for debugging purposes is packet capture. Packet capture starts here. After you enable it, you say, I want to run a packet capture on a specific device. Now, some of you are familiar with Wireshark. You're familiar with packet capture? Yeah, cool. So think about it. If I'm a backend developer and I'm looking at my server and I'm debugging because this user and that user are not behaving as I expect them to behave. So I'm opening a Wireshark and I'm looking at the packet capture and I'm seeing that they're sending malformed information, or my server is not reacting according to what I'm expecting. Packet capture really allows you to tap into the wire, or this virtual wire, and look at the packets going in and out. It's a great debugging tool. Most backend developers constantly use it. Usually front-end developers don't really need it. When you're developing a device, this is very, very similar to being a backend developer. The device is kind of your server. So think about that. You guys are developing traffic light controller, and you deployed it to a few testing sites. You got maybe 5 countries. You got 2 traffic lights in Brazil, and 2 traffic lights in Mexico, and 2 traffic lights in the UK being tested. Just think about the fact that you can remotely tap into those devices and ask for the packet capture. Look at the real bits and bytes. Now, I want to show you an example. This is how you set up the packet capture. You define the duration. So I've done a nice example that I want to show you here. So I've already done a capture. I'll open it up. This is a bike, a Segway bike that we have. And we're looking through the SIM card that we have inside of this Segway bike. The Segway bike is yet another IoT device, yet another connected device. If I want to lock it or unlock it, or what happens if this scooter gets stolen or just falls in an area without coverage. Using Monogoto and Skylo, we are able to get the location even if there is no cellular coverage. So here you can see the TCP and the bits and bytes that are going from this device. If I look at a specific TCP stream and I'll try to follow it, we can actually see the communication going in and out. Now, this is binary, so looking at textually doesn't give us a lot of information, but you can see from the color changes, the discussion. Bytes are being sent, bytes are being received. So we can actually tap into a Segway scooter that can be in a different continent and actually look at the bits and bytes. Now, for the use case that we're doing here, for example, for the bird listener, one of the great use cases that you had here, packets were sent here via this dev kit, and we wanted to verify if the packets were okay because the server was rejecting it. That's when we did the packet capture, looking into the packets and seeing if the packets are being sent in the right way or not. That's where we saw that there was some syntax error inside of the data. We go to the code, we fix the code, upload it to the Raspberry Pi, and now the Raspberry Pi is able to communicate with the server according to the rules that we define. So this is an amazing tool that allows you to debug connected devices in real time, regardless if that device is connected to AT&T, to T-Mobile, to a network in Spain, or to the satellite network. So with this capability, with the ability to do packet capture, you can really look at the bits and bytes, and it helps you to develop faster. Now, if we're going back to our dashboard, where we can see this, here is the place where we can run the actual captures. Now, what happens when you go out of here and you say, oh my God, this was awesome. I've got a friend who really wants this and really needs to test it. So in the order section, and by the way, we have some promo codes, so we're not talking about money, we're talking about the accessibility. The most important question that we heard here today is how to get started quickly. So you go to the orders and you say, I'd like to create a new order. Demo, so let's hope everything works. The God of Demo is with us. And now we'll choose the satellite. This is the dev kit that we're talking about that we have here today. So you click on the satellite, you need regular SIM cards, maybe you need some more because you want to test, it doesn't matter. You click next. Again, come ask me for the promotion code. This is just a way for you to be able to continue to develop this outside. You get some details to see in front of you what costs, etc., etc. We're not worried about prices at the moment. You do next, you put your address, and that's it. We ship it to you. In the payment section, that's where you put the promo code that we give you, and that's it. The same kit that you had today, you get shipped to you. So how do you get started? You go to Monogoto, you open an account, you use the dev kits that we gave you today, or you purchase a new one with the promo code, and then you get the kit sent to you. You'll get the kit, you'll get the SIM cards, everything configured under your account, and you're golden. You can get up and running extremely quickly. Now, once you're inside here, and once you see the themes and the networks and everything, like I showed before, this is the most important part. Developing connected devices is not easy. Our job in life is to make it easy. We lower the barrier. That's what Monogoto is here for. Now, you know what's the best way to lower the barrier outside of APIs and technology? You know what's the best way? To stay in touch. So here is where you can contact us. You can see it on top. You can open a ticket with us. You can chat with us. We've got WhatsApp, and we've got Slack, and we've got email ticketing. Just ask us questions. And we have people that their job in life is to make developers happy. It's unattainable, but we can do the best that we can in order to help you and in order for you guys, to move faster. The time to market is very important. So if you have a question about architecture, about APIs, about anything, we can really help you. Now, the last thing I'll say, in order to have all the information with you, you need resources. So when you log in, you can see the resources, but you don't need to be, let's do monogoto.io. You don't need to be a Monogoto user in order to get the resources. So here you can see the resources, you can see the documentation, you can see some blog posts, and from here, you can get started with everything. What happens if I want to disable a specific country? Or what happens if I want to lock the device to a specific network? What happens if I want only 4G and to disable the rest? What if I want to do a firewall rule or ports? Everything is here. What happens if I want to start with my new NTN, the non-terrestrial kit? So you go here, you search for NTN, and you get all the information you need. So what is NTN? What's the coverage list? What's the Skylo? What are we doing? And basically all the information is here down to the API level. And again, if you want to disable a specific firewall or ports, you go here, you do firewall, and you get all the information, how to block URLs, IPs, ports, etc. With this entry point, with our documentation, the world is your oyster, so get your oyster connected. Thank you very much for listening. Thank you so much for being here.
Are we taking questions?
I think we have another one.
Perfect.
Yeah, but if you want to answer questions, you can.
Yeah, just back it up.
Sounds great.
Any
Yeah.
questions? By all means.
Thank you all.
Amazing.